This video is on types of structures and how to solve for them, and mainly nothing else. But before we get started, we have to go through the 5 different types of structures and the 2 types of geometry we have to solve for when we do these. So, the first type of structure we should all know is linear, which looks something like this. It's straight, it's flat, and it's nothing more. Then we have bent, which is 2 atoms, and this one is not flat. Trigonal planar, which will look something like this. Trigonal, I'm spelling this wrong. Trigonal pyramidal, which will look something like this, and then we have a tetrahedron, which will look like this. And we know these from Chem. If you don't, that's what they look like. These are very important. Now, there are 2 types of geometries. There's molecular geometry, which I'm going to call MG when I'm doing my examples, which is only atoms. And then there's electron geometry, which I'm going to call EG in this video, which is both unpaired / lone atoms, which are non-bonding, and bonding atoms. So, let's get to going with these examples. So, let's start with hydrogen sulfide. So, hydrogen sulfide is H2S. And I'm using all examples from the worksheet assignment we did. Now we know that hydrogen sulfide has 8 valence electrons because hydrogen has 2, and because of the 2 right here, and sulfur has 6, there's 8. When you draw it, sorry. Before you solve for what structure it is, you have to draw the Lewis dot structure, Lewis dots first. So sulfur in the middle, H. Hydrogen can only have 2 valence electrons, so the other 2 go in sulfur. Now, we have to figure out how many domains there are in this. So, to solve for domains, or figure out domains, you ignore the middle one, and we circle the rest. So, one domain, hydrogen, because it's one of the bonded atoms. Hydrogen's another bonded atom. And we also count lone pairs in this. So, in this one, there are 4 domains. So if we were to let's just figure out the electron geometry, this would be a tetrahedral. Because 4 domains, 4 atoms, that is what a tetrahedral is. It exactly has 4 atoms, 4 domains. Now, when we solve for molecular geometry, on the other hand, we don't count these lone pairs. These mean nothing in molecular geometry. So, with molecular geometry, this is 2, and so it's either going to be linear or bent, and since the structure is going to look something like this, this is bent, because it is 3D, because of these 2 ones up here, but these don't, these are unpaired, and these 2 are the atoms, so this is bent. Another example of it being 2 different things is ozone. Ozone is O3, and it has 18 valence electrons. So when we draw ozone, it will look quite like this. Now, electron geometry-wise, this has 1, 2, 3. 3, making this trigonal planar. But With molecular geometry, we know that we do not count the lone pairs, making only 2 atoms, and since it will look very similar to what is up here, well, looking more like this, this will also end up being bent. It's also why when we got this on our worksheet, it was already in this bent looking shape. Let's do an example of what a trigonal pyramid will look like. So this is nitrogen trifluoride. So NF3 26 on 36. Sorry, 26 valence electrons. Draw the Lewis structure. It will look like this. Lone pairs and everything else has. Alright, so again, they ignore the middle and figure out how many domains there are. 1 domain, 2 domains, 3 domains. We also count the lone pairs, so 4 domains. Yeah, 4 domains. So this means the electron geometry will be a tetrahedral. 4 domains, a tetrahedral. That's what it'll be. Tetra means 4. So that is usually a hint. Now, this, to solve molecular, we know that we now ignore the lone pairs. So we have 1, 2, 3. And this will not actually be a trigonal planar because with it being a tetrahedral, it will look like this. But since one of these is not a full atom, this ends up making it 3D, which means it's trigonal. I love my room. Trigonal pyramidal. How do you spell that? Alright. Example of oxygen is CO2, which looks, I'm not gonna draw it. I'm just gonna draw how to do it. So C linear kind of looks similar to this. That is what CO2 looks like. There is 2 on the side. There's nothing there. So both the electron geometry and molecular geometry would be linear. Now, methanol is a little different, where this will end up having 2 different answers. Now, methanol is CH3OH, 14 electrons. So, to draw it, COH, we still need 4 more valence, so there it is. Now, with this, it is a tad different, as the shape is a little bit more. We want to focus on separating it. So, if we focused on carbon being the main one, so we ignore this while solving for it, we figure out that there are 4 domains connected to it. Connected to carbon specifically, 4 domains. So carbon has 4, which makes this a tetrahedral. If we were to focus on oxygen being the central, we ignore it. 1, 2, 3, 4, making this also a tetrahedral. So in both instances, this is a tetrahedral in the electron geometry. Okay. Now, here's the thing. In this shape, there are 4 proper electrons connected to the carbon. 1, 2, 3, 4. So this molecular geometry ends up being a tetrahedral, correct? But if we focus on the oxygen, there are 2 lone pairs. So we're going to have to ignore those and only focus on these 2. So this shape would actually be bent for the molecular geometry because of the 2 lone pairs, they can only have 2 atoms connected to it, meaning it is, again, bent, because this one should only have 2 atoms. So in this instance, methanol has not only a tetrahedral for molecular geometry, it also is bent at the same time because of the 2 various ones. And that really is how I solve for it. It's more of figuring out how many domains there are, and if there's more than one like this, you want to split it up, finding the two different centrals, and just picking and choosing which one would match the description. If it's 3D with 3 atoms, then it's trigonal planar. If it's flat with 3 atoms, then it will be trigonal pyramidal if it's 3D and 3 atoms. If it's flat with 3 atoms, then it's trigonal planar. And remember that the electron geometry is different from the molecular geometry, as molecular geometry only deals with the atoms, while the electron geometry deals with both the bonded and non-bonded pairs, which means the atoms and the lone pairs themselves.